Today, we will see how do we multiply and divide expressions with rational exponents. Now, the main idea here is that we're going to follow the rule of exponents that we know. Where the rule of exponents that we know is that if you're multiplying, you're going to add the exponents, and if you're dividing, you're going to subtract the exponents. That is if both of them have the same base. And then we're going to get an answer. And that answer, we're going to rewrite that as a radical form, which means we're just going to rewrite that as a square root form. That's all we're doing right here. We're going to apply the rule of exponents to simplify. And that simplification, we're going to rewrite that as a square root form. And that's all this is saying. So we follow the rule of exponents to simplify rational exponent expressions. So let's get started. Now, again, the main idea here is the task that we're asking us here is that we want to write the following as radical expressions. So now what this means is that we have this expression. We need to rewrite this as a radical expression, which is just saying we need to write this as a root where we use this symbol. So how can we go from here to just a root? Well, we're going to apply the rule of exponents that we know here. And the rule of exponents says that, well, again, I guess the numbers are too big, but all of them here, they're exponents. So this is x exponent 2/3, x exponent 5/3. Now, what it means here is that, notice that we're multiplying here. And when we multiply and they have the same base, what do I know? I can add the exponents. So x 2 to the 3rd times x 5 to the 3rd, this is the same as x 2 to the 3rd plus 5 to the 3rd. Because that's what the rule of exponents is. If you have the same base, which we do, and you're multiplying, well, you're going to add the exponents, which in this case are pretty big. Now we're going to concentrate the roots here. We're adding two fractions. So you got to remember that if we're going to be adding two fractions, the denominator needs to be the same. They're the same, so we can proceed with the addition. So 2/3 plus 5/3, that's the same as 7/3. And now, according to our previous video, we know how to go from here to a root form, which is saying, what's your base? My base is x. We want to write this in radical form. Denominator becomes my root, which in this case is 3. My exponent is my numerator, which in this case, that's 7. And that's all there is to it. You perform the operation, which in this case multiplication is addition of exponents. So we have this, then you're going to add, then you got to remember that your numerator is your exponent and your denominator is your root. Let's continue with example 2 now. Again, we're multiplying, they have the same base, so we can add the exponents. So now we have x 4/5 plus 3/5. All right. Now, can we add those fractions? Yes, we can, because they have the same denominator. So now this becomes x 7/5. So now that we have this x 7/5, we know how to go from an exponent to a rational expression, radical. We're here the base is x. Then we're going to write this as a root. And you got to remember that your denominator is your root, which in this case is 5. And your numerator is your exponent. So now we're going to raise all this to the 7 exponent. Let's look at example 3. So notice that here we have the same base, they're multiplying, so I can add the exponents. So now I have x 3/2 So we got x 3/2 plus 5/4. Let's rewrite that. 5/4. So if we're going to try to add those fractions, if we're trying to add those fractions here, notice that they don't have the same denominator, so we cannot just add them right away. So now we got to think back to Algebra 1. If we want to add those fractions, they need to have the same denominator. So let's look at the denominator, 2 and 4. Notice that the greatest denominator that they have, that will be 4. So the left side, we need to make that into a 4. So we can multiply top and bottom by 2. Because if we do that, then we have x 6 divided by 4 plus 5 divided by 4. Now that they have the same denominator, then we can add them now. So now this becomes x 11/4. Now that we have this, then we can rewrite this as a radical expression. So the base here is x. We're going to write our root. Now you got to remember that your denominator is your root, and your numerator, which in this case is 11, this is your exponent. So now let's look at another examples here. So this is what happens when you are multiplying. So what happens when you're dividing? It's pretty much the same idea, but now the rule of exponent says that if you're dividing, now we don't add, but we subtract. So let's look at example 4 here. Oops, sorry about that. Let's look at example 4 here again. So now this is what we have. We're dividing, and I know that the rule of exponent says that if you have the same base, you divide, you subtract the exponent, so that's exactly what we're going to do here. So now it becomes 2/5 minus 1/5. We take care of the numerators, they have the same denominator, so I can subtract the numerators. So now this becomes x 2 minus 1, so that's 1/5. And now that we have into this form, we know how to go from here to square root form. So now we write the root, base is 5, the base is x, denominator is 5, numerator is 1. So denominator is 5, so my root is 5. Numerator is 1, my exponent is 1. We don't need to write that exponent because it's 1, so this is it. Let's look at example 5 here. Again, you're dividing, you subtract the exponents, so now this becomes x 5/3 minus 2/3. So now they have the same denominator, so I can subtract them. So now this becomes 5 minus 2, so that's 3/3. Well, even though this can become 1, which this can just be x and then call it, because 1 divided by 1 is just, 3 divided by 3 is just 1. But let's omit that, and let's just actually write this in square root form. So now this becomes x root, my root is 3, because my denominator is 3, and my numerator is 3, so that means that my exponent is 3 as well. So now let's look at our last example here, in example 6. Same idea here. We're dividing, so we need to subtract the exponents. So now this means that we have x 7/4 minus 3/2. So notice that here we don't have the same denominator, so we need to make them have the same denominator. Notice that the greatest common denominator they have is 4, so that means that the first fraction I can multiply top and bottom by 2 to make this denominator into a 4. So now this becomes x 7/4 minus 6/4. Now that they have the same denominator, I can subtract them. So now this becomes 7 minus 6, so that's 1/4. Now we can rewrite this into root form. So we have a root. What's my base? My base is x. My denominator is 4. So that means that my root is 4. Numerator is 1, so we don't write that exponent. Here's your entrance ticket. Try to write the following in radical form. Oops, omit this t, radical form.